Okay, a real quick video on our first drawing for MDA2. I want to discuss working space. So just as an introduction to working space, let's just go through it as a practical understanding of what we're talking about here. When you are working below ground level, let's just take this elevation or section as an example. So you need access to the surrounding areas, particularly when you need to add formwork, right? So in instances where something is cast against an excavated surface, you don't need access, and I have seen this practically on site, that they just cast against the excavation where you're allowed to. In some other places, they might require you to use formwork. In this drawing, because this is cut back at a 45-degree angle, the formwork to contain the concrete when it's cast in this footing needs to be placed there. And some might argue that the blinding can actually just be cast against that angle and might be fine. And others might say, well, just put a piece of formwork all the way down and use the full height. I'll check the memo which one we used. So that's just a brief idea. So I'm going to do it in blue where we need formwork. So obviously this wall, the foundation wall is concrete, reinforced concrete. So we're going to need something to retain all this concrete that's pushing against that side. So what they would do is, without actually cutting back, I'm just going to draw that they would have to prop this nicely to hold that, retain that pressure. There's a hydrostatic pressure from the concrete that gets poured into this formwork. So from that face and on this face, remember when you're measuring foundations is from NGL downwards. So both faces, let me just erase this top piece, want to be kicked out, as they say. Formwork gets kicked out by pressure from the concrete. So just a brief idea. Okay, that piece is going above NGL, but don't worry about it. So for the sake of measurement, that's what our formwork will look like for the foundation wall. Then for the footing, and there's a spec that you need to see, but I'm just going to draw it for you now. There's a piece that goes there that will also be propped or strutted up, and this face does not get formwork, and you'll see now why. It's specified, and that face doesn't, and I'll discuss that now as well. This one is not part of the footing, that's soil on this face. So basically what we are looking at for this drawing, let's do it in red here. 1, 2, 3 needs formwork. Okay, that is all we can deduct from the section. Now if you move over to the plan, let's just make it clear here. So that end A, so these are where the walls meet the excavation and run up to natural ground level. Okay, these walls are inaccessible, right? And you might say that's fine. You're just going to cast against it. But I think we'll see now, according to the memo, that it's the spec is that there's to be formwork to retain that concrete. So we cannot cast against the soil. And if we can't cast against the soil at areas A, we are going to cut back. We're going to have to cut back to put our formwork in. So over here, let's just do cutting back in red. We're going to cut the box, and the soil will actually just continue where it is around it, but you're going to make that void in the surrounding soil up to NGL. Now it's not entirely practical, but this is how it is measured. And once you cut that void, your formwork is going to be placed in there, on both ends, and then similar to what we have here with the propping, is we're going to prop that little piece against the surrounding soil. This is top view, so you have to visualize this kind of stuff. Is it's going to be above the footing, and there's going to be a tiny little slither inside there. What would happen in reality, I think, would be a much, well, firstly, yeah, I can draw this now. In reality, but not how it's measured, is that I would say that space is much bigger. Just for the sake of interest, I would say this probably, if this is 200 wall, and you'd probably want space for propping as well, so you know, it might be an extra 200 on each side. And then for your shuttering or formwork would be like that. And then so if we start numbering these, you can get quite an interesting picture of what we're doing. We are molding the negative space. So the positive space is, you know, the structure you want to remain, and the negative space, so we're making a mold. And you'd put formwork there, and I think just to be safe, I'm going to draw it as if it's measured. Okay, formwork there, exactly that size. There, you've got 1 and 2, so 1 is on this face, running that side. 2 is on this face, running this side. Okay, and 3 will be this piece on the footing. And then you back prop everything. Let's number that 2, and let's make this one 3. So that's what the propping looks like. The cutting for that one is like that. This one like that. Now, it's not so obvious how this slope needs to be cut, so I'm just going to cross over to the memo now to check. So in the memo we've got that it's currently cut to the angle of repose. The angle of repose is the angle at which a material has not reached its sliding moment. So a sliding moment is sort of the point at which a material starts to trickle or slide down a slope. So the friction amongst all of these little particles is enough to prevent the gravitational force from pushing it downwards, right? Now, if it's on top of each other, gravity will overturn these top little pieces to run down, sort of as a slope, as a little avalanche. So if it's at its angle of repose, we're happy that it's not going to overturn. Then we move on. What was the next thing here? It's worth noting that formwork for concrete that cannot be cast against excavated faces. Okay, that's a rule I see has been put here twice. I'm not sure why it's not under wall. It's under blinding and strip footing, but it actually should be here as well. It should be in 3 places, I think. So that's what we take out of that. 1 and 2. Then we have this one's interesting, equal to, less than or equal to. So I'll tell you something interesting about this scenario, less than or equal to, particularly with this drawing, is that this will be tested directly. That there will be an item that's on 600, and I'll tell you why I had a problem with the drawing. Just go back. So I'm going to erase a nice little diagram with the propping and everything. So firstly, if we follow our rules, where concrete cannot be cast against excavated faces. And that was in, take a look here. Yeah, so it was basically what I drew previously. That rule about where concrete cannot be cast against excavated faces was that rule of, you know, to retain the concrete from the pressure it's exerting. You can't just be cast in air. You're going to make the mold, prop it up, and that's how it's going to be cast, from NGL downwards. But in this case, for the slope was an interesting case for me, because what I picked up is that is 450 to that point. Okay, so that's 450. And since it's at 45, this is also 450. Okay. So 450 is definitely less than 600. So you know that you need to do some back excavation there to make working space. And that instance is clear enough, and maybe let's draw it so it's, you know, clear. Let's say we want to know exactly what's happening here. I'll do it in red. So that could potentially come out. Okay, what else do we need? So we know that spot. What about this spot here at the bottom of the foundation wall? So that distance is 150, and we know this one was 450. So this, from the wall to the slope, is 650. So that, oh, sorry, not 650, 600. Yeah, I picked it up. It's a special case because it is exactly on 600. Okay. So what was the rule? Less than or equal to 600. This happens to be equal to 600. So the first millimeter after this 450 box needs to be excavated, needs to be cut back. Right there needs to be cut back so that we reach, we exceed the 600 requirement. But all along this face here is actually greater than 600, right? Because if that's 650 from there, sorry, not 650, 600, and we know this is increasing. This one could be, let's say 850, and from there we say this one's 950. So technically speaking, everything along this slope is actually fine. There's plenty of working space, but I'll tell you why we still measure this full height. So we've decided that above this 450 box we're happy, that it actually is enough space. I mean, it's 850, 950. The only thing was down here, which was 600. You know, if you want to be, you know, a bit ridiculous, yes, cut out a 1 millimeter for the guy so he has access to work there. But in my mind, it's sort of okay not to measure it. And this is where I was wrong, is the standard system, and if you follow, you know, pretty sound logic, says that you must measure this full height from NGL to the lowest point that you need access. Okay, and the lowest point is 500 plus 400 plus 50. So this is 950. So you might say it looks like you've exaggerated what you really need. Do you really need 950? I mean, you only need this little box here actually, right? And I would agree. But if you are to excavate this little box, my first argument is that this, since it's at the angle 45, it's going to collapse. So it would collapse and fill up this space. And sorry, it wouldn't be like that though. So you'd cut and it would collapse to that line. So you'd you'd first start digging out. Just run through the process and visualize it. You're digging out and carting away. And every time you're digging out, it's collapsing down here and building up. Building up, building up, building up. And then, relatively close to the 45 degree. Then you take out your tape measure and you measure this, and you'll see, okay, it's now, let's say you reach 600 or 500, and you do the process again. You cut away and it starts collapsing and pushes that line back again. Right? There. And then you take your tape measure out, you say, okay, it's the minimum, it's 600. That's enough space for you to work in. And then through that process, unfortunately, you've ended up taking out a lot of material, not just from this area, but by the nature of it sliding down, you've ended up taking away from the top as well, which wasn't really necessary, but by the by physics of the material, it happened by itself, and you can't prevent it. So the standard system is, I don't know if this is the logic that goes through it when they develop these things, but to me it actually makes a lot of sound logic. Is that you cannot excavate an area lower than without accounting for what's above it. If you take this as a case, if you want to excavate this face, you're going to have to go through all of this material up here. Right? You're not going to dig a cave just for the footing. It's just too impractical. You can't do that. Whilst this stays, in place, it wouldn't happen. You'd have to excavate the entire height. So that's what has to go through your mind, is like, okay, you might only need this point at the bottom and it's super small, and maybe it will cross your mind to just measure that, right? Because you're over measuring by a ridiculous amount. But now that we've gone through the logic, you actually are not over measuring. In a practical sense, you are doing exactly what would happen on site. You're going to cut straight down through the material above it, and then to get to what you really need. Right. Okay, so that's pretty much what I explain. In the 90-degree example, you're going to have to cut through material straight down. In the sloped example, you're going to have to cut through material that's falling down. And then there was a third example where it's sloped but maybe not falling. And I would say, well, just to maintain the character of the diagram, you would still just cut it back. You'd probably cut, so you'd want 600 there, and let's say it's less than 45, it's now 30. You would replicate it, and it'd just be 30 over there. So in my mind, full height makes perfect sense, and it also makes perfect sense to start at the lowest position that you need working space from. Okay, if you start here, you've not accounted for all of the space down here that you need working space. And if you start at the lowest point, remember you've accounted for everything above it, so you don't need to remeasure it. So that's about it for running through the details of it. So let's just take a look at the memo quick. Okay, risk collapse, water, rough formwork. So this measurement 0.45 is the footing and the blinding I see. So some people might say you don't need formwork for blinding, but in this example we've measured to include the blinding. So that face gets formwork, and I guess if you want to have a system in your mind, it's to not calculate where working space is, but to first calculate where formwork goes, because that's pretty straightforward. It's obvious to you that concrete can't defy the laws of physics. It needs to be retained. Okay, you're gonna put formwork to retain concrete. That's the first step that should go through your mind. Then you should ask yourself, now what are the rules? Okay, the guy needs access. Whoever's installing this formwork, he needs access of 600 or less. 6 no. So you must measure working space if it's less than or equal to 600. So 500 is less than 600, which means, and another interesting part about measuring working space is that you do not quantify how much extra he must cut back here. It's not actually of our interest. And I don't know, this might come up later on in the course, but maybe it should be measured because 500 only has 100 mils of cutback. Okay, this point, so let's say it was like you needed to cut back from 100 to 600, then you would have a 500 mil cutback, which is a lot more work. But anyway, in terms of measuring, we are only interested in instances where it occurs, not how much, but only where it occurs. Okay, and it is the length times the height. So this was running that way and that way, 4,300, and this little piece is 500, as we know. So all this is 4.3, 0.5. That's that working space calculation because of the formwork. Because in your mind you say, how is this guy gonna put the formwork in? Okay, and then your question is, okay, so now he's got space, he's put the formwork in, he's gonna prop it up with solid timber SA pine, and yeah, that's that. And then you'd go, well, you need formwork to hold up the footing. You do the cutback exercise. You might run through the logic that I've said, where it's going to run down, you're going to cut back and run down, and it's going to be a fight with gravity, and eventually you would reach the same situation where finally you've met the criteria of 600. And it doesn't actually say you must meet the criteria of 600, but I assume this is the process that happens, is that finally he meets his minimum of 600 here, and obviously this is going to be vastly bigger. It's 950 plus 600, so it's going to be that space is going to be huge now. Anyway, he meets his quota, his requirement, and props it up. And then same story here, but by virtue of you doing the bottom, you don't have to remeasure the top. The bottom one was a single measurement of 4,300 by the full height, 450, right? 4.3, 0.45 is your plywood, your formwork, sorry. And then when it comes to, so let's just put your formwork, and then for your working space is the full height. And I've gone through this a couple times now. It's the full height because you have to. There's no other choice. You have to go through that material. It's going to slide. Maybe you're just going to replicate the profile of the slope. Again, it doesn't matter. You've got to do the full height. 50 plus 400 plus 500. 0.95. And it is a square meter measurement. Like I said, we're not concerned of how far back you're going, how much this material is. You know, it could be a huge amount, it could be less. We just want to know, okay, square meters, you're going to cut back, make some space so that he can put his formwork and his propping. So I think I've satisfied that. I haven't spoken about the ends, but the ends are pretty straightforward. It's because the wall, and I think it must be in the spec. So what's interesting, the wall actually doesn't have it. So let's just check. Let's take a look at the wall. Might be a problem with the spec, or maybe a problem with how I'm reading. So the wall is 0.2, right? So I see we've got a measurement for making working space, right? Where's the formwork? Okay, that's the formwork. So the formwork falls into less than 300 mil wide. So you just do a linear dimension, and there's two ends. So let's just take a look at this one. The back excavations, it falls into this category, right? I haven't spoken about the category, but it's 500 to 500, not exceeding, sorry, less than 500. Then it's 500 to 1,500, and then it's I think it might be intervals of 1,500 after that. I'm not too sure. But our back excavation for the ends, two little ends of 200 mils each. So we're looking at, where do we want to look here? Let's look here. Okay, this is 200, and this one's 500. So like I said, we just want a square meter measurement. We're not concerned about how much you must dig. This actually is the biggest example of how much you need to work, because the minimum is 600 and it is flush now with the excavation. So that is quite a big cut back or back excavation to make space for that work there. But we don't concern ourselves with that. It's 200 by 500 and there's two of them, and each one looks like this. 1, 2, little box cut out there in the soil. It's not practical, and I've been through why, but that's not a concern for us. And that's that. I just want to go across to some drawings of working space. So if you do some investigating, this one for example is a video, but okay, well now I've lost the picture. Here we go. So you can see how much extra they end up cutting back here. But just take a look at a couple of practical examples and you can see clearly why we need working space. When formwork comes in, it's and I've worked in, like for instance, this one is actually not great. I've seen, it's not like ease of access, and working in situations like this actually quite important to get good quality formwork and like it's propped properly. It's not going to fail or kick out. It's plumb, these things need working space so a laborer can actually do his job to a high degree of quality. That's for footings, and I just wanted to check foundation walls. So if we take this as an example, if you've already excavated for the footing, this looks really high already. This is the wall. We've already come out of NGL. But let's just use an example. If you've already made working space for your lowest area you need access, by virtue of cutting at the bottom here, you've also got to cut away at the top. So measured once from the lowest point. That rule should make perfect sense to you, because I've explained it a couple of times now. That is that, I think, for working space. I'm gonna call it quits on this video, but we will tackle whatever interesting comes up next, probably next week. Thanks for listening, guys.